Okay, now just to brush up on what we did last week, or whatever time we came. What's today? Thursday, Tuesday. What we did Tuesday, and that is we turned the corner with the quotient, difference quotient, as well as the derivative. So let's go ahead and do one more, just for get everybody in the thinking mode. Let's do f of x is equal to 3x. Okay, let's do the square root. That'll be good. Square root of x squared minus, actually, x squared minus 3x. Now it's going to be hard to check it with the derivative law because we've got to use the chain rule, and we haven't learned the chain rule yet, so it's going to be kind of hard. But Mr. Patel, do you ride a motorcycle? Oh, I just wondered. You have the orange shoes with the orange pack. I didn't know if you rode a motorcycle or not. They'd be good to ride a motorcycle with. People see you. You practice on that reverse foil anymore? Not really? Okay. Well, you can make them up. No, you can't. But you can Google it. There's one thing I do agree with Trump on, is we've got to quit telegraphing whatever we do in the military.
Talking about, I'm not going to tell my plan to the whole world.
Yeah.
Like Obama does?
Yeah. We got to quit telling people what we're doing. I agree with that 100%. I don't care whose candidate is. We're going to come in with an invasion, and we're going to pull out on the 15th. Not very smart. Oh, fluoride and apple juice. Good combination. No, fluoride and acid actually causes chemical reaction. So Tim Tebow's going to the New York Knicks. Baseball team. Yep. I think he'll probably do good. I think he probably would have done good in football, but he was never given a chance, in my opinion. If he'd done drugs and been thrown in jail a couple, 3 times, he would have been all right. It's sad to say. And Dumbbutt is going back to college. What's his name? Yeah.
Have you seen it? It's like,
yeah, that's what that crack does to you. Mm-hmm. That is one, he can go down as one of the stupidest players in history. There's been a few of them. He's one of them. Had the tiger by the tail and didn't have enough sense to grab it. All right. Radicals and calculus do not what? Do not mix. So in this case, you got f of x is equal to x squared minus 3x, and that's to the what? 1/2 power. Guess what? You can't do much with that. You can't do much with the 1/2 power. Because in algebra, there's nothing, what can you do with x to the 1/2 power? All you can do is change it to the radical. But in calculus, you can use what we call the chain rule. And I'll put it right here. You can write it down, but we're going to go over it again. The chain rule says that you need to treat this as 2x squared and do the basic rule, 2 times 2 minus 1. Do the basic rule and then take the derivative of what's inside. Okay, that's the chain rule. So, in this case, f prime of x would equal 1/2 x squared minus 3x, 1/2 minus 1, and then the derivative of what's inside. What's the derivative of x squared? 2x. And what's the derivative of 3x? Minus 3. So, let's clean it up. Oh, that's all the calculus of is. Rest of it's what? Rest of it's out. So f prime of x is equal to 1/2 times x squared minus 3x raised to the what? Minus 1/2 times 2x minus 3. Now I want you to clean that up. Because calculus is done. I've been showing you the calculus. All we're doing now is algebra. First thing I would do, I wouldn't even do anything except for write it all out the way it's written. Because I'm a very basic type guy. If I get confused, I try to get the basics down. So x squared minus 3x to the negative 1/2 power over 1 times 2x minus 3 over 1. So maybe that might help you. Now, algebraically, what can we do? Quit. It's always an easy thing to do. You're all failures. What causes a problem when you look at it? What? Enunciate in volume. What? The negative exponent. Everybody should be looking at that negative exponent and going, ugh. So what do? Flip it. Use the inverse rule. So that will give us f prime of x is equal to 1/2 times 1 over x squared minus 3x to the 1/2 power times 2x minus 3 over 1. Now, see if you can do anything more with it. I'm going to make it small. I'm going to mess it up. It's conspiracy. So f prime of x is equal to 2x minus 3 over 2 times the square root of x squared minus 3x. Now the only other thing you could do is what? Multiply the top and the bottom by the square root of x squared minus 3x and simplify it a little bit. That's about all you can do. So I'm going to take my handy dandy blue pen and I'm going to multiply by the square root of x squared minus 3x over the square root of x squared minus 3x. And that may help us out a little bit. It's going to give us 2x minus 3 times the square root of x squared minus 3x over 2 times x squared minus 3x. And you can distribute that 2, but that's about it. So this is a possible answer. This is a possible answer. And 2x minus 3 times square root of x squared minus 3x over 2x squared minus 6x. Now, that's about it. There's 3 possible answers. I don't really care which one you do. The whole point is, another reason for showing you this type problem is 90% of this is what? Algebra. You're starting to see why people suck at calculus. It's probably not because of the calculus, it's because of the algebra. All right? So, let's talk about the calculus. We've done talked about what is calculus. It's basically the limit plus the algebra, finding the slope. Now let's talk about the rules of calculus. The rules of calculus, let's go with notation first. I don't understand why this does this. There. I don't understand. I've had too much training, is what it is. There we go. All right. One of the basics. F of x is equal to x squared plus 2. Notation. F prime of x means what? The derivative. F prime of x. That's the one I like to use the most. Okay? And for those of you that have a book, you'll have to find out where it is, but I think it's in, let's see, where's the ebook? I think we're starting the fundamental differentiation rules right in here. Yeah. D over dx is another way. Somewhere in here, they show you the different ways, what I'm fixing to go over, if I could ever learn how to use this thing. They show you the different ways of writing the derivative, d over dx. There's the basic, probably before that somewhere. Limits and derivatives, maybe down here. There's the difference quotient. Well, somewhere they show you how to write it, and that's what I'm fixing to show you, but I wanted to give you a reference of where we were in the book. We're somewhere between chapter 2 and 3. I think the last part of 2. But anyway, you can follow along in the book if you have one. F prime of x is one way of writing the derivative. Another way of writing the derivative is d over dx. I don't usually write it like that. I try to stay away from the complicated stuff. You can deal with the complicated stuff after you take first and second calculus. Then you can deal with the complicated stuff. Dy over dx. And then in implicit differentiation, you can do dx over dy, which means you take the derivative of y in respect to x. But I try not to use this. All right. If you had it written as y is equal to x squared plus 2, then you could say y prime is equal to whatever. All right, so you're going to see me use this a lot. I'll use this a lot. I very rarely use these. Okay, but you can use them if you want to. You're used to using. Now, that's notation. So we covered that, and that's good. The basic rule of the derivative is if I give you a x to the n power, then the basic rule says that I take n and I multiply it by a, and I take the n and I reduce it by 1. And that's the basic rule of derivatives. The fundamental rule of derivatives. Example. 3x to the second power is equal to 2 times 3 x to the 2 minus 1, which is equal to 6x to the first power. Now, yes, I write in the first few problems we do, I usually write the exponents as they are with 0 and 1, because when you find yourself confused, you can always go back, and I'll show you that in just a few minutes. And with that 0 power, you'll see why the constant goes out. We'll do one right now. Let's do the derivative of 4. Okay, well, like I told you in algebra, there's always a variable and a coefficient, whether it's there or not. The variable here is 4. I mean, the coefficient is 4. But the variable is what? X to the 0 power. So if you remember that, then you know that the derivative of any constant is what? 0, because the 0 cancels everything out. That's why I tell students to remember. And that goes to 0, so therefore, the derivative of a constant, it will always be equal to 0. Now, the reason I wrote d over dx here is because you can't write f prime of x of c. That's not good. That's not good notation. So if you take the derivative of a constant, it's best to use that like this when you're writing a rule or something. So what about, how about 4 over x to the third power? How would you do that? Some of you people that's had calculus before, how would you do that? Rewrite. Rewrite is one of your biggest advantages in calculus. When it comes to negative exponents and what? Radicals. Okay? Rewrite. So you would rewrite this guy as 4x to the what? Negative 3, and that will give you negative 12 x to the negative 4th power, or negative 12 over x to the 4th power. Now, 2 hints that I've given you. 1, always keep in mind that there's always a variable and a coefficient, whether there's one there or not. 2, rewrite whenever you've got a negative exponent or a radical. So let's do a couple. Let's go with 4x to the 5th power. Let's go with 1/2 x to the 4th power. And let's go with 3 over x to the negative 12th power. Pretty basic. And the basic rule of derivatives is called power rule. So you might want to write that down. Power rule. Also, what's the first one? 5 times 4, x to the 5 minus 1, 20, x to the 4. Four times 1/2, x to the 4 minus 1. What's 1/2 of 4? These two are rewrites. Exponent over index. Exponent over index. Two-thirds x to the 2/3 minus what? 3/3. This is where you stare at -1 for 15 minutes. Not know what to do. 4/5 x to the 4/5 minus what? 5/5. And of course, that's going to leave you with 2/3 x to the what? Okay, it's gonna switch. A while ago, it was an eraser. Okay, somebody figure that out. I have too much training. That's the problem.
Is this called Epsom Smart Board?
Yep. You can Google, you can get it. I've been Googling for the last 2 years. They've got 3 videos, and it shows the guy, he don't even touch the board. He just comes in here, this can do this can do this, and he'll show you how to use it. I've even contacted the Southeast Regional Manager for training and gave her name and number to our IT division. That was about a year ago. So, you can get it. Good try though. I have tried to find a training session that I could go to. If I can take a pay for it. Nope, nothing. They just put something out there and don't have what? Training.
I don't know, it's like I would buy something like that.
All state government. Federal government's worse. Federal government would have bought an Epson projection system with a Promethean and then not give you training on it. Anybody in here ever work for the federal government? Am I right? And then sell you a hammer to hit it all for $500. Now, what can I do with that x to the third? Bring it down, right? And that will give you 2 over 3 cube root of x, and you can rationalize. I'm going to circle both of them because at that point, that's just a little bit of algebra, and we're not worried about that.
Is that down underneath the denominator for 3 types of cube root of x, or is that 2/3?
Well, this x to the negative, that's over 1. So if you want to flip it, and it comes out. And then you can rationalize to the cube root of x. No, you rationalize with the cube root of x squared. That's what you would rationalize as. So this one would be 2 cube root of x squared over 3x, right? So either one of those 3 answers would work. And the same thing here. This would be 4 over 5 x to the negative 1/5 over 1, 4 over 5 fifth root of x. So that's one answer. Of course, you wouldn't write 4/5 x to the negative 1/5. That's be wrong. And then this would be 4 fifth root of x to the 4th over 5x. So there's your 3 possibilities for that. Now, the whole purpose for me showing you this stuff, these 5 basic, is because where is the calculus? The calculus is right there. The calculus is right there. The calculus is right there. And the calculus is right there. And right there. The rest of it is algebra. Now, is that going to go away after the basic rule, or is it going to keep piling on? It's going to keep piling on. So if you suck at algebra, you're going to suck at calculus. You get tired of hearing me say that. Hopefully you will, and it's kind of reverse psychology. Maybe you'll quit. No, I'm just kidding. All right. Why? This might be my student yesterday. Why do you tell people to quit? It's a joke, people. It's called a sense of humor. You don't have one, okay? You have to ask. Huh? No. I'm such an impolitically correct person. We need safe zones on Tri-County Tech. That's what we need. I'm going to tell the president we need safe zones. So all the wimpy ass, so all the people that feel inferior can go to their little safe zone under the tree. I'm sorry. Goes fine and go with that. All right. Now let's do the product rule. The product rule is when you use a certain rule for when you've got two things that you need to take the derivatives of via multiply. Product multiplication. Remember your product rule of exponents? Well, this is your product rule of calculus. And it basically says first times the derivative of the second plus the second times the derivative of the first. Now this is Hubertism. You're not going to see that in the book. In fact, if you want to look at it in the book, I wouldn't suggest it. But we'll look at it so you can see. But after this, I usually don't show you. No, somewhere in here. I don't know where it is. Let's see. There's the product rule. Now, if you can't see it, I'll blow it up because you need to see, again, why people don't understand calculus. They don't understand calculus because they're not a Philadelphia lawyer and understand that. When do you understand that? You understand that when you're in your second and third semester calculus. All right? So, it's either show you that and let you be totally confused, or show you what I show you and let you learn and grow into that. Because some of you hadn't grown into that. Some of you haven't had the calculus background, like I did, to know what that means. So when you're shown that and you're given a presenter, and the presenter presents this and says this is the product rule, then you sit there and go, okay, what does that mean? Well, it means first times the derivative of the second plus the second times the derivative of the first. Capiche? All right, that's why I don't show you. But we'll use an example. Let's see if we can find an example. Next page. There we go. I don't want to start with e to the x, that's for sure. I don't want to start with that. They give you the hardest examples to start with. And then they give you the quotient rule. Well, that sucks. Hold on. Let me go to the homework. I'll find the one that's a good example to start with. Here's your product rule right here. They don't give you, is there no? Huh. They don't even give you any examples here. They give you two examples right there. The rest is quotient rule. Well, I'm not going to do that. We're going to do something, I'm going to give you something easy to start with. So, how about 2x f of x is equal to 2x times e to the x. Now, which way do we read? Left to right, unless it's in the Middle East, Masalama. If we're from here, we read left to right. So, the first term is this one. The second term is this one. The derivative of e to the x is e to the x. Shouldn't forget that. So, plug it in there. First times the derivative of the second, plus the second times the derivative of the first. to, I'll write my e to the x and then I'll say prime. And I'll take my handy dandy highlighter. I'll highlight this guy. This guy. So, f prime of x is equal to 2x times e to the x, because the derivative of e to the x is e to the x, plus e to the x times what? Times 2. And to rewrite this, you'd say f prime of x is equal to, you can put the 2x in front or behind, I don't care, I'll usually leave it out front, 2x e to the x plus 2e to the x. And what can come out of those two? And always try to factor out, because in calculus they want you to leave it in the most simplified answer. So you can take out a 2e to the x, and that will leave you with x plus what? 1, Hubert. That's right, guys. Okay. Now, this is considered an answer, but I'm just telling you, most of your calculuses wants you to factor out what's in common at the end. Okay? Yes, ma'am. That's factored out. I factored out this. I factored out the 2e to the x and the 2e to the x. I factored that out. Okay. Now, there are other ways that you can do these type problems. Like, for instance, if I gave you f of x is equal to x squared times the square root of x. Somebody tell me how you can solve that. It's not solve it, but find the derivative. What's the two different ways you could do it? One, use the product rule. Because I'm talking about the product rule, yes, use the product rule. What's the other way? Change it. What? Change the radical, because radicals and calculus don't mix. But what can you do after you change it to a radical? Add the exponents. And then you have just your regular. So do it both ways and see what you come up with. What we're doing right now is we're setting the foundation. If your foundation sucks, your house is going to fall down. I'm going to go to the next page. F of x is equal to, what was it, x squared times square root of x? F of x is equal to x squared times square root of x. times the derivative of the second plus the second times the derivative of the first f of x is equal to x squared times x to the 1/2 power. F of x is equal to x, and that's 4/2, 3/2. So f prime of x is equal to 3/2 x to the negative what? Negative 5/2. I'm sorry, it would be negative 3/2. This would be minus 2/2. I'm sorry, I'm thinking of something else. I'm sorry. Three minus 2 is 1/2.
Should be 3 has to be 5.
That's what I thought. Where? I thought I had it right. You know what's wrong? I can't do my math for having to do this stupid board.
This is the right one.
No, then we spend a half the time erasing boards. Yesterday it worked fine. I didn't have a single problem yesterday. It's y'all is what it is. Okay. Just like Hillary's allergic to the board is allergic to y'all. Yeah.
Maybe because your computer inspected already 100%, maybe someone's messing with it, so you start.
No, then that'd take 20 minutes. So we're screwed either which way. All right, 4/2 times x to the 1/2. Okay, that'd be 5/2. There. Boom. All right, and you can play with that. If there's nothing really you can do with that, that's pretty much going to be the answer. You can put 3 times the exponent over index, the square root of x to the 5th, and then you can reduce that down some, but I'm not worried about that. That's just a little bit out.
That was the problem.
No, that was rewriting. Rewrite and then use the power rule. Then power. This is the product rule. F prime of x is equal to x squared times the derivative of x to the 1/2 power plus x to the 1/2 power times the derivative of x squared. F prime of x is equal to x squared times 1/2 x to the what? Negative 1/2 plus x to the 1/2 times 2x squared, or 2x to the first power. And then this is f prime of x. And you can, I'm going to write everything out for you. It'll be x to the 1/2 times x to the negative 1/2 over 1 plus this, which you can go ahead and do 2x to the 2/2 times x to the 1/2. That's all we're going to do there. And then over here you can flip this, and that's f prime of x is equal to x squared over 1. 1 over what? 2x to the 1/2 plus 2, and what's x times x? What did it come up with? X to the 3/2. And then this is going to be the quotient rule. or you can go ahead and do this right here. Basically, you're going to get what's x to the second plus x to the negative, or times x to the negative, be 2 minus 1/2, which would be 4/2 minus 1/2, which is what? 3/2. So that's going to give you, I done got lost. X to the 3/2 over 2. Y'all check me. Plus 2 x to the 3/2. Go with me? And you keep going, you'll get that up there. You gotta get a common denominator. But you'll end up with that right there. Again, the whole point of me showing you these two is to show you the only calculus is one sentence. The rest of it's algebra. Okay? And that's going to give you a 2, which will give you a 4, and then that's going to give you x cubed, and it'll turn out to be that right there. But the whole point is you can do it 2 different ways. You'll see this a good bit with the quotient rule and the chain rule. You can do either one. You can do the product rule, quotient rule, or the chain rule. Chain rule is a little bit to itself because it's kind of like different, all right? But sometimes you can move if you've got a quotient. Remember, let me show you. You remember doing the product rule with x squared times x to the 4th, and you said that x2 plus 4, y'all remember doing that? Right? And then you were given the quotient rule, and the quotient rule says x to the 5th over x to the 3rd is equal to x to the 5 minus 3. Remember doing that? But somebody said, well, you can use the inverse rule, and you can pull this up here, and it would be x to the 5th times x to the negative 3rd, and you can use product rule. You remember thinking, well, you can do the same thing with your product rule, your inverse rule, and all that good stuff with derivatives too. You don't have to do it one certain way. Okay? So, let's look at the quotient rule. And the reason I'm moving kind of fast is because you're not learning very much. You're doing a lot of algebra. So, let's look at the quotient rule. And the quotient rule is denominator times numerator prime minus numerator times denominator prime over denominator squared. That's the quotient rule.
I'm sorry, what is the quotient sign? On the product rule, what's the quotient sign?
That's showing you take the derivative of the term. That's what I showed you the first screen, remember?
I just saw you show it, but
Well, I done lost it. There it is. If I want to take the derivative of a term, here's the term. If I want to take the derivative of it, that's what the prime is for. That's telling you, take the derivative of this term. That's what that little prime is right there. Okay? So, on the product rule, right here, the first term times you take the derivative of the second term, plus the second term times you take the derivative of the first term. That's what it means. Same thing with the rule I just said, the quotient rule. Quotient rule says, write the denominator down, then take the derivative of the numerator, then you're going to minus the numerator times the derivative of the denominator and put it over denominator squared. Now again, if you like whips and chains, then go to your handy dandy book, and somewhere there is the quotient rule. Now you tell me, if you're right out of high school and you haven't had a little bit of pre-calculus, tell me what that would do to you if you looked at that for the first time. Some of you may be out of high school and not out of, what does that do? You can call it. I mean, do you sit there and go, oh yes, I understand that? If you do, you need to be at MIT, not at Tri-County Tech. All right? Or you've had a couple of semesters of calculus, one of the two. Because that, to me, is confusing. Or am I crazy? All right, so look at this guy. Oh, I wanted to show you one more. Let's show you one more that you might do that is, you can do two different ways. Take a look at this one. I'm going to try to, f of x is equal to x plus 3. See, what this means, I'm writing, look at there. There's a dot right there. Where is that dot? Times x minus 2. Now, what's one way to solve this? By the product rule. Another way to solve it is by doing what method? FOIL. Then take the derivative of the trinomial. Or you could just quit. Quit. Quitting is easier. So I'm going to put a handy dandy dividing line right here. And f of x is equal to x squared plus x. You need to lay off those Marlboro Reds. Minus 6. Now the first thing that's going to happen when you do the product rule with the first third is you're going to lock down. Some of you are just going to sit there and stare at it. Why? Well, what's the derivative of x? 1, Hubert. That's right, class. What's the derivative of constant? So what's 1 plus 0? So the derivative of those are going to be 1. See what I'm saying? It's not very difficult. Unless you just sit there and stare at it. I know none of y'all are doing it, right? F prime of x is equal to, taking the derivative now, first times the derivative of the second plus the second times the derivative of the first. First, now what is x minus 2? What's the derivative of x minus 2? Well, the derivative of x is 1. Derivative of 2 is 0. So 1 minus 0 is 1. Plus x minus 2. And what's the derivative here? 1. So f prime of x is equal to x plus 3 plus x minus 2. You got a 1 here, you got a 1 here, distribute that 1, distribute that 1. We get f prime of x is equal to x plus 3 plus x what? Minus 2. What's x plus x? 2x. And what's 3 minus 2? Now let's go over here. f prime of x, and since these are added terms, you can just take the derivative of each one. What's the derivative of x squared? What's the derivative of x? What's the derivative of 6? No, listen. Doesn't matter how you do it, as long as you do it legally, mathematically, then you'll get the same one. Answer. Remember your exponential laws, remember your logarithmic laws. The derivative laws follow the same pattern. You don't have to do it in a certain order as long as you do it correctly. You can take the inverse and move it up and do the product rule, or you can do the quotient rule. You can do separately, or you can put them together and do them. It doesn't matter. Quotient rule is the same way. If you want to move the denominator up and change it into a negative exponent, then you can use not the quotient rule, but what can you use? The product rule. So there is no methodical way of doing it. I want to make sure that's clear, because some of you may start by using something else and you may think, I can't do this. Yes, you can. Okay? So let's go back to the quotient rule. I just wanted to show you that one because you might see that one on the test. Okay. There's the denominator, and let me pull up. We'll just make one up. I don't like making them up that much because sometimes they don't work well. They don't play well with others. Let me look and see if they got one. There's one right there. X squared plus x minus 2 over x cubed plus 6. Write that down and I'll write it up here. Some of you that can write fast. X squared plus x minus 2 over x cubed plus 6. All right, now let me go to the whiteboard. X squared plus x, whatever. I done forgot it. I have no short-term memory. I have long-term, but I don't have short-term. All right, what is it? X squared, f of x is equal to what?
X squared plus x
Over
x to the third plus 6.
Now, you could make this x to the third plus 6 and bring it up here and make it negative 1, but then you'd have a total cluster. You don't want that. There's nothing wrong with you using different methods if the work is not extra, but you don't need to reinvent the what? The wheel. Your parents did good. Those of you that have no idea what I'm saying, your parents cheated. Reinvent the wheel. Or, if you don't want to reinvent the wheel, if it ain't broke, don't fix it. Don't go out looking for extra work like some people do up here at Tri County Tech. Have to have an in-class test. Have to have an in-class test. Make your attention go down. Anyway, or make your students have tests and papers due on Labor Day. That way, half of them won't show up, and you can have more conflict in your class. Anyway, I'm sorry. I'm just venting there a little bit. So, here's the denominator times the numerator prime minus the numerator times the denominator prime. So go ahead and set it up. And it may be a little bit more intimidating than you think. It may turn out to be real simple. One of my students told me, gave me a suggestion for one of my classes online. How to use calculator. I'm going to do that. I gotta find a calculator online that I can put at my home computer. That doesn't give you 15 viruses.
There's someone who could noticing that
I saw that.
they have the calculator. And she suggested, at first I thought it said it was offering tutoring. And I thought it said also need help with calculator. If you're a tutor, why do you need help with the calculator? But I saw she needed tutoring, so I asked her, I said, you know, if I plan to offer tutoring. She said she knew, but she had a busy schedule anyway, so she somehow talked me into helping.
Well, if you get it over your head, you can holler at me. I'll be glad to help. Okay. But I'm gonna make it. I'm gonna make it free. So I had to write it down on a piece of paper yesterday. So the only thing I have is a receipt. So I had to write it down. Any other ideas? Let me know. Thinking about doing a class on there about word problems too. Just have a class on 50,000 word problems. That's a good idea, dude. Well, accept you. Thank you for the interaction. Appreciate it.
Sounds like that.
Yeah. I think heaven is Athens, Georgia. That's heaven. You ever been to Athens, Georgia?
Yeah.
You need to go.
Were you guys in there?
No.
Yeah.
Okay. Athens makes Clemson look like the jockey dog. Them dogs, I guess. I'm gonna hate to see Alabama come to Athens if they're coming to Athens this year. It's gonna be rough. What I'm really gonna hate to see is Alabama go to South Carolina. I don't think anybody's gonna be able to stop Alabama this year. The USC just sucked me too. Maybe the ACC can slow Alabama down. I don't have any football fans in here, I can tell you. Huh? I'm sorry, you said too fast.
You watching it?
No, I don't like the Panthers. I like Atlanta. Because Atlanta came out when I was born. The Atlanta Falcon team was born, I think, 66 or 67. And I grew up watching them. And they're like the Braves. They blow it. They choke whenever they get to the playoffs. It's like the Braves. So. They did make it one Super Bowl, right? Or two. Yeah. Atlanta made it to one, I thought. Yeah, either they got right to it or I thought they got one.
They got to,
Yeah. And they choked. They got beat like 21-0 or something. They got choked. They choked. All right. So here we go. For those that quit and are meditating on first our denominator times numerator prime minus the numerator times the denominator prime over denominator squared. Now, does anybody notice something that I did? Anybody notice when I was writing this part right here, something that I interjected, something that I injected, whatever you want to call it? Huh? Enunciate and volume. Okay. Ooh, you were good. All right. What did I do? Something very basic. Brackets. Why did I put the brackets right here? Take my handy dandy highlighter. Why did I do that? Oops, that's supposed to be a bracket. Why did I do that?
Well, because we had two parentheses in there.
No, that ain't got anything to do with it. You're a loser. the negative sign. Why? Because that negative sign is your nightmare in this problem. Because, let me ask you a question. Have you done the calculus? Yes, the calculus is done. You just did the calculus. All that's left is what? Algebra. And what kicks your rear end in algebra? That negative sign in front of a whole kit and caboodle of stuff. Because that negative sign changes what? Every sign. And that's where you'll make your killer mistakes. What we call. Yeah, well, we got to do this little bit of calculus right here. Yes, you're right. But as far as the main calculus, we've set it up. But the rest is. Yeah, exactly. So x cubed plus 6. And then what's the derivative of x squared? And 1. Minus brackets, parentheses, x squared plus x minus 2. What is the derivative of 3x cubed? 3x squared. All over x cubed plus 6. Okay, now you need to work on the second part for those that were meditating. And you can go ahead and do the FOIL method with the first part. Yeah, it is. I'm sorry. I thought I squared it. I didn't. And that's shortcut number what? Denominator shortcut number 1. You and a friend of mine's got the same thing. Sinus trouble, allergies.
I think it's going around.
Well, it's because the season's changing.
We got a house with all the humidifier and analyzer and all this stuff.
I haven't even read in my house. I guess that's why I'm dealing with this. So, f prime of x is equal to 2x to the 4th plus x cubed. Oh, I'm sorry. I was doing distributive law. X cubed, that'd be x cubed there plus 12x plus 6. Y'all check me. X cubed. I was doing distributive law. Let me start over. I was distributing the first term. Okay. First is 2x to the 4th. Two x to the 4th. That's first. Outside is x to the 3rd. Inside is 12x. Last is 6. Is that what y'all got? Oh, that's what I got first time. Minus brackets 3x to the 4th plus 3x to the 3rd minus 6x squared, checking, over x cubed plus 6 y squared. I'm not really too concerned about the denominator yet. F prime of x is equal to, well, this makes this, and I'm going to take my handy dandy red marker, and I'm going to turn that into a negative, and I'm going to turn that into a negative, and I'm going to turn this into a positive, and then I'm going to take my eraser, and I'm going to erase that and that. Now I skipped a couple of steps doing that, and y'all should be algebraically mature enough to know why I did that. And that's going to give me 2x cubed, or 2x to the fourth minus 3x to the fourth is what? Negative x to the fourth. And x to the third minus 3x to the third. Plus 6x squared. Plus 12x. Plus 6 over x cubed plus 6 quantity squared. I don't see any reason to go any further because nothing's going to factor out. Now, let's talk about it. What was the calculus? Well, the calculus was the first two what? Steps right here, right? Did you say that was your calculus? The rest of it now. Let's see where they took it in the book. Because I don't really see any reason for going any further than that. Is that what they did? Check that answer. Is that what we got?
Yeah.
Let's see if there's anything on the next. Nope, there's nothing on the next page. So now I want to spend the rest of the class talking about the chain rule, and then we're going to put all of it together. And right now I am doing 3.1, 3.2, and 3.4. I'm not going to take a break and do the trigonometric functions, let you forget what we went over here and here, and then expect you to remember it when we get to 3.4. So we're going to move 3.3 down to 3.5 or something. We're not going to worry about that right now, okay? And you can't understand really the trigonometric functions until you understand the chain rule, because sometimes the chain rule is involved with the trigonometric functions, especially when you have the sine of 2x. Well, the sine of 2x, the 2x is in the parentheses, and you have to take the derivative of what's inside, and that's why there's a 2 in front of the cosine, and people say, where did the 2 come from? Because you have to know the chain rule. So we're going to move, that's not right. That needs to be moved down here. So we're going to go over the chain rule. Now the chain rule pretty much is one of the most misinterpreted rules there are. And the reason it is why. Let's look at it so we can see how people are getting confused. That's how the chain rule is written. Now, like I said, if you come into calculus for the first time, and I throw that on the board, and I say, okay, this is the chain rule, let's do some examples. You're going to be like, what the heck does that mean? Well, I'm going to show you. The chain rule says basically, you're going to use two rules. You're going to use the power rule, and then you're going to use a basic rule to take the derivative of what's inside. What's inside is what's inside the parentheses. So if I give you f of x is equal to the square root of x plus 1, that's it, square root of x plus 1, something simple. The first thing you're going to say, Mr. Clint Scales, is what? Yeah, what are you going to do? You're going to change it, because radicals in calculus what? Don't mix. And if you've ever had me for calculus, you know I say that throughout the whole first semester of calculus. So f of x is equal to x plus 1 to the 1/2 power. Anytime you see a 1/2 power, chances are you're going to be using the chain rule. Now, the chain rule takes two things and puts them together. The power rule, do the power rule, and then do the derivative of what's inside. Do the power rule, then the derivative of what's inside. So, what am I going to do? The 1/2 comes out front. And then minus what? 1. And that's the power rule. Now I'm going to take the derivative of what? X plus 1. Now this one's very basic, so you're going to have a lot of 1's floating around, and 1's doesn't change. But when we do another one in a minute, and we put x squared plus 2 in the radical, or 2x, then you're going to have something else to deal with. So, here we have 1/2 x plus 1 to the what? Well, 1/2 minus 2/2. And then the derivative of this is 1. And then the 1 times this, that's the multiplicative identity, so you don't have to worry about that. If it was 2, then you'd have to worry about it. But 1 times 1/2 is 1/2 times x plus 1 to the negative 1/2 over 1, flip it, and that gives you 1 over x2 times x plus 1 to the 1/2, or 1 over 2 square root of x plus 1. Or x plus 1 over 2 times x plus 1. Square root of x plus 1 on top, you rationalize the denominator. But the whole point is, the calculus for here is right here. There's the calculus. You do the power rule, and then you take the derivative of what's inside. Now get used to that derivative of what's inside, because you're going to see that over and over and over in the problems we're going to be doing in the future. Derivative of what's inside, derivative of what's inside, whatever's inside the parentheses. Okay? So let's do a nerd. F of x is equal to 2 square root of x squared minus 2. While y'all doing that, I'll call the roll. If you can't do it, we'll just go ahead and fill out a drop slip. I didn't hear y'all. Nope. Just so I don't have all that humidifier. What do you call it? Ionizer? That's what it
Actually, it
is.
makes it hotter in the house, too.
Ionizer. Ionizer. Never heard of one of those before. Oh, it is. Well, it would probably fail at my house, living in the middle of the pasture.
No, we live in the house.
Oh, you do?
And we've got the house was built in the 50s, so 60s.
Mine was built in the 50s too, but I moved it from town. I can't do anything the simple way. I have to do everything the hard way. So I moved the house, put it in the middle of a pasture, stripped it down, and had my buddy build around it. I can't do anything simple. But that house ain't going nowhere. I guarantee you it's made out of that old raw boards, sawmill boards, 2x4s like that. It's built in the 50s because we found a nickel in each wall. 1951, 52 nickel in each wall. And that's something carpenters do or something. I don't know. Found a buffalo nickel in one. My friend who's like a third or fourth generation builder said that they used to do that to date the house. Mine's dated in the 50s. All right, who's here? Ahmed. Andersons are here. Caldwell. Flint Scales is here. Cook.
Here.
Briggs. Grant. Hernandez. Huth. Johnson. Jordan. Marshall. Patel is here. Fan. Scobie. Salih. Sheik is here. Silver. And Tucker. Tucker. So Miss Tucker is not here. She's the only person that's not here today. All right. So let's go to our problem. What?
She wants to say we had this before.
Today is not a good day to miss. Today is really not a good day to miss. But maybe she'll watch a video. Hope she does. If she doesn't, I'll feel I've dropped it. So, what do? Quit? Please do it. All right. So, f of x is equal to 2x squared minus 2 to the 1/2 power. And now we have the chain rule. So that's going to be f prime of x is equal to 1/2 times 2 times x squared minus 2 to the 1/2 minus 1/2, 2 halves. And then what's the derivative of this? 2x. And see, this is what people do with chain. They forget that part. And then they forget to pull it out front, and it's going to make it cancel out here somewhere. And that's what people forget. F prime of x is equal to 2x times 1/2 times 2 x squared minus 2 negative 1/2. And of course the 2's cancel here. And I'll do this for you. 1 times 2x is 2x. F prime of x is equal to 2x times x squared minus 2 to the negative 1/2, which will give you 2x over what? The square root of x squared minus 2.
Yeah, I'm just using those 2x.
What do you mean?
Is it because we do negative 1/2?
This is the power rule. And then what do you do with the power rule? What do you do after the power rule? Of derivative of what? Okay. So what's the derivative of what's inside here. What's the derivative of x squared minus 2?
Well, it's 2x, but
Got to take the derivative of what's inside. That's the whole part of the chain rule that people forget.
so you,
What?
so you take the derivative and then you
Usually this derivative right here is going to come out here, and most of the time there's going to be some kind of canceling or combining of it. But you don't have to, but most of the time that's what happens.
okay, the reason why we had last problem is because
The one. Yeah. That's why I see it. All right. So let's do another one more. F of x is equal to 3x times the square root of x cubed minus 1. Let's do that. Now there's something different on this one too. What is it? I'm sorry, what? Well, the x is out front, and that changes the whole diameter. Now you can't just use the chain rule. You've got to use the chain rule plus what? Product rule. Good. What book is that? What is it? I mean, Machine Man? I got 15 minutes of fame. I'm in a book. I'm in several books. You ever heard of Ron Rash? I'm in several of his books. That's my 15 minutes of fame. That's probably the only 15 minutes of fame I have. Huh? Yeah. 2 of them are movies. Serena, I'm a mountain. McClure Mountain and McClure Campground. You have to look because he only mentions it twice. And then I'm also in Saints at the River. I'm a deputy. And in World Made Straight, I'm a Marine veteran that come home that grows pot, and I have a peace symbol around my neck. He did that just to piss me off. My name is Hubert Toomey.
Hubert what?
Toomey. Toomey. And my great-great-great-grandfather was a Confederate soldier named Hubert Sherman McClure, and that's in the book. He was a good friend of mine, still a good friend of mine. He's all over the place now. They love his books in Europe. He's like a main seller in Europe.
Yeah, we have to do that. We do really next too.
Ron wrote a short story about me and him going to New York, and me driving a pulpwood truck, and we put a bunch of pine trees on it and selling those Christmas trees in Central Park on a pulpwood truck. And he wrote a short story of him and I going up there, and it was interesting. He never did publish it. I wish he did. It's funny. Where are you boys from? 6 Mile? 6 miles from what? Huh? I don't know. It's basically first times derivative second plus second times derivative first. Now to get it down to the end, and if you want to make it into a similar fraction, I mean a simpler fraction, you would have to get a common denominator. I have to see what the answer is before I can tell you. First times the derivative of the second plus the second times the derivative of the first what's the derivative of this one? Well, we gotta bring out 1/2 x cubed minus 1 to the negative 1/2, and then what's the derivative of x cubed? Plus x cubed minus 1 times what? What's the derivative of 3x? Well, I'm gonna bring that 3x and that 1/2. I'm gonna bring that all out. 3x times 1/2 times 3x squared, and then you can bring this down, and that's going to be x cubed minus 1 to the 1/2 power plus 3 times, or 3x cubed so it was right in yellow. Now it's right in black. There's no pattern whatsoever. It's just, everything's arbitrary. Everything's just sporadic. But that's what all that training is for. 3x cubed minus what? No, can't do that. That's shortcut number 5. That's going to be a cluster. So I'm just going to rewrite it as 3 times x squared minus 1. Because you got to expand that before you can. That's x cubed x minus 1 times x squared plus x plus 1. And then you have to distribute. So we're going to do that alone. Over here, this is going to be f prime of x is equal to 3 times 3 is what? 9. So it'll be 9/2. Y'all check me. X to the third over x cubed minus 1 to the 1/2 power plus 3 times x cubed minus 1. We'll leave it right there because you don't want to expand this, and you can rationalize this. This thing.
Yeah, that would be this term, but was it plus x to the cube and then plus 1? How do you do that? That's
1/2. Good. Then that way that's better. So that's why you were asking about a common denominator. I wouldn't. The one thing you could do, you could factor out. You could do that. Leave this as a negative. Hold on. That's going to be 9. Really? Nine times x squared, x cubed, 9/2 x cubed, and leave this x cubed minus 1 to the negative 1/2, and you could factor out x cubed minus 1 to the negative 1/2, pull it out, but this is probably good enough.
Cross out the x cubed minus 1 to the 1/2.
There's not one up top.
There's
Not one here. That's plus. I can't do that. You know that. That's algebra. That's basic algebra. X plus 2 over x. You can't cancel those x's out. That's the same thing. X plus 2 over r. You could do it like this. 4 over x plus X. You can't cancel those two out because of this. You can only cancel one's multiplication. Now, let me ask you a question. And I'm talking mainly to those people that have had this before. I just went over 3 sections. I went over the basic law, I went over the product rule, went over the quotient rule, went over the chain rule. How are we feeling? Pretty good? Okay, 2 people said pretty good. Okay, out of 19. And half of those people have had pre-calculus or, what the heck is this? Really? I've never had that come up before. It quit recording. Now it's just going to quit recording whenever.